Hello, this is Mr. Rose, and this is lesson 4.2. This is a two-part video, and this is the first of the two parts. You should fill out your note sheet as you watch the video. This is the last lesson in Unit 4. This has been a short unit, only 2 lessons long. And today we're going to be talking about solving right triangles. So if you want to solve a right triangle, that means that you want to find the measures of all of its sides and all of its angles. There are 3 sides and 3 angles. So you're going to find all of those. Some of those will be given to you, and you will have to find the rest. You can solve a right triangle if you know either of the following. 2 side lengths or 1 side length and 1 acute angle. Remember, we're dealing with right triangles, and we know that the right angle measures 90 degrees. So you either have to know 2 of the side lengths, and you can use the Pythagorean theorem and some inverse trig functions to get the angles. I'll talk about those in just a moment. Or if you know 1 of the side lengths and 1 of the angles, you can use the trig ratios to find the other side lengths and subtract from 180 or subtract from 90, whichever one you want to do, to get the other acute angle. Now, if you look underneath what we've just written here, there is a thing about inverse trigonometric ratios. You use these when you don't know the angle, but you know the sides. And we're going to see some examples of that in play here in just a few moments with some examples. But what you do basically is use the inverse tangent or the inverse sine or the inverse cosine button on a scientific calculator. You put in the ratio of the sides for tangent or sine or cosine, use the inverse button, and that'll tell you how big the angle was that made that ratio. And that button on the calculator looks like this for tangent, and this for sine, and this for cosine. You'll have to use a scientific calculator in order to access those functions. So if you're using the Desmos calculator, make sure you're using the scientific version of that calculator. Let's look at some examples of solving the right triangles. I'm going to do these 3 on this video, and then I'll do the backside of your note sheet on the next video. I just want to break this up a little bit so that it's not so long. On number 4 here, we see that we are given one of the acute angles and the hypotenuse of this right triangle. Now, when we want to solve the right triangle, we want to find all 6 pieces of the triangle. So what I'm going to do is I'm going to list all 6 pieces and write down what I already know. We want to know the measure of angle P, the measure of angle Q, and the measure of angle R. We want to know the side length PQ. We want to know the side length QR, and we want to know the side length RP. All right, I'm going to move this up just a little bit here to give us some more room to work. All right, we know the angle Q is the right angle, so I'm going to make that 90 degrees. They gave us that. They gave us angle R, that was 37 degrees. And they also gave us the hypotenuse, PR or RP, which was 22. So we know 3 pieces. We need to find the other 3 pieces. So here's what I'm going to do. I'm going to start off by finding angle P. Angle P can be found by remembering that the 3 angles of a right triangle add up to 180 degrees. Now, If the three angles of a right triangle or any triangle add up to 180 degrees, and we know that one of the angles is a 90-degree angle, that means that the other two angles have to add up to 90 also. So I can either subtract 90 plus 37 from 180, or the quick and easy way is just subtract 37 from 90, because those two acute angles have to add up to 90. So the measure of angle P is equal to 90 minus 37, which comes out to be 53 degrees. So now we have all three of our angles. Now, if I want to find the missing sides here, I know an angle and I know a hypotenuse. What we want to do is use some trig ratios in order to figure out the missing sides. In relation to 37 degrees, this is the opposite side, this is the hypotenuse, and this would be the adjacent side. So if I want to find PQ, I am looking at the opposite side and I know the hypotenuse. So if I look back at SOHCAHTOA, opposite and hypotenuse is going back to sine. So I'm going to do the sine of 37 degrees is equal to the opposite, which is PQ, over the hypotenuse, which is 22. Remember, what you want to do here to get the PQ by itself is multiply both sides by 22. And when you use a scientific calculator that's set on the degree mode to get the answer here, the answer comes out to be 13.2 for PQ. Now, in order to find QR, QR is the adjacent side, and I know the hypotenuse. Adjacent hypotenuse is cosine. So I'm going to do the cosine of 37 degrees is equal to the adjacent, which is QR, over the hypotenuse, which is 22. And just like before, I'm going to multiply both sides by 22. And when I work this out on the graphing calculator, or not on the graphing calculator, the scientific calculator, I come up with 17.6. So now we have solved for all 6 pieces of the triangle. We know the measures of angles P, Q, and R, and we know the measures of sides PQ, QR, and RP. This is what we mean by solving a right triangle. Now, before I go on to the next example, I do want to point out something to you. Notice that I did not use any of the measurements that I found in my calculations. I always use the measurements that were given to me in the original problem. The reason for that is it's not a good idea to use found measurements in your calculations, because if you made a mistake, then you're going to make another mistake when you use it to find another measurement. So make sure that you use only the measurements that were provided for you in the original problem. All right, let's look at the next problem here, number 5. This time we're given 2 sides of the triangle and the right angle. So let's make a list of our pieces again. We've got the measure of angle Q, the measure of angle P, and the measure of angle N. And as far as our sides are concerned, we've got QP, and we've got PN, and we've got NQ. All right, we know that QP is 11. We know that QN or NQ is 18. And we know that angle Q is a 90-degree angle. Now, this time I don't know another angle, so I can't do the subtraction from 90 to figure out how big the other angles are. We'll get back to that in just a moment. But I do notice I've got two of the three sides for the right triangle, and that means that I can use the Pythagorean theorem. All right, the legs are the 11 and the 18 sides. So 11 squared plus 18 squared equals the hypotenuse, which is Pn squared. Now, when I work this out, and I work out the powers here, 11 squared is 121, 18 squared is 324. And when I add those two together, I get 445. Remember, the way to get rid of a square is to take a square root. So I'm going to take the square root of both sides. And squares and square roots cancel out, so that leaves Pn over here. The square root of 445, if you round it off as a decimal, comes out to be 21.1. And on these problems, we do want you to round these off as decimals. One place after the decimal point will be fine. So Pn is 21.1. That gives me all three sides. Now, as far as the missing angles are concerned, we're going to have to use those inverse trig functions that I was talking about earlier. Let me bring this down just a little bit here so we can have some more room to work. If I want to find the measure of angle P, for example, I went down too fast here. If I want to know the measure of angle P, notice that I know the opposite side and the adjacent side. This is the hypotenuse right here. So if I know the opposite and the adjacent side, that is tangent. So I want to do the tangent of angle P is equal to the opposite, which is 18, over the adjacent, which is 11. Now, in order to get rid of a tangent, we have to do the inverse tangent. Okay, so if I do that, the inverse tangent of the tangent would just be the angle. So P equals the inverse tangent of 18 over 11. You will probably have to write that in parentheses when you put it into your calculator. If you don't know how to access that button on your calculator or how to use that properly, please contact me and I will get with you and help you figure that out. Okay? So this is all calculator work right here. When you put that in your calculator and work it out, we get P is equal to 58.6 degrees. Now, at this point, you could subtract 58.6 from 90 to get the other angle. But like I said, it's not good to use a found measurement in finding the other measurements. We could use that as a way to check ourselves when we're finished here. But let's go ahead and use the inverse function here again to find angle N. Trying to find angle N now. And in regards to angle N, we have the adjacent, this is now the opposite side, and this is now the adjacent side. So we have opposite and adjacent again. So once again, we have tangent. So let's go ahead and work that out here. We've got the tangent of angle N is equal to 11 over 18, the opposite over the adjacent. And N is equal to the inverse tangent of 11 over 18. And when you work that out, N comes out to be equal to 31.4.
Monday, how about Tuesday?
I'll be with you in about 15 minutes, okay?
Over answer the 18th.
All right, we have one more problem to go over here. Problem number 6, and I'm probably going to have to erase some of this in order to fit the work on there. So I'll let you pause right there for a moment if you need to copy down information. All right, let's look at problem number 6 now. All right, on problem number 6, we have the measure of angle S, the measure of angle T, and the measure of angle U. We have the measure, whoops, it's a side, not an angle. We have side ST, we have side TU, and we have side US. All right, now once again, just like on this last problem, I've got two sides of the triangle and none of the acute angles. So let's go ahead and find the other side by using the Pythagorean theorem. UT is one of the legs, and TS is the other leg, and US is the hypotenuse. So we've got TU plus 7 squared, TU squared plus 7 squared equals 23 squared. All right, 7 squared is 49, and 23 squared is 529. I'm going to subtract 49 from both sides. And 529 minus 49 is 480. I'll take the square root of both sides. TU rounds off to 21.9. All right, now in order to find my missing angles, I'm going to have to use these inverse trig functions again. Okay, so the first one we're going to look at is angle S. And in regards to angle S, I know the adjacent side is 7. I know the hypotenuse is 23, and I'm missing the opposite side. So in terms of SOHCAHTOA, again, I've got adjacent and hypotenuse, that is cosine. So I want to do the cosine of angle S is equal to the adjacent, which is 7, over the hypotenuse, which is 23. In order to get S by itself, I want to do the inverse cosine of 7 over 23. And when you work that out on your calculator, that comes out to be 72.3. All right, now in terms of the other angle here, angle U, this would now be the opposite side, and this would now be the adjacent side. So this time I know the opposite and the hypotenuse, that is the sine. So the sine of angle U is equal to the opposite, which is 7, over the hypotenuse, which is 23. And I want to get rid of the sign by taking the inverse sine of 7 over 23. When you do that, sine, or the angle U comes out to be 17.7 degrees. And we didn't mark it here. Whoops, I put it in the wrong place. Let me fix that real fast. Angle T was 90 degrees. We should have written that one in there earlier. So angle U was 17.7 degrees. Okay. We also should have written in the other measurements that we knew. ST was 7 and US was 23. Now we know all 6 pieces of this triangle, and this triangle has been solved. Make sure you copy all these down to use as examples for when you do your assignment. There is a part 2 to this video, and it's just more examples of these, so I hope that you'll watch that as well and copy down those examples too, so that when you do your assignment, you'll know what you're doing. Thank you.